Welcome to Frequency Matters, the RF and Microwave Update series. Thank you for joining us today. I'm Jenn DiMarco, and alongside me is my co-host, Tim Rainear. Our sponsor for this episode is RFMW. RFMW is a technical distributor of RF, microwave, and power management products. As you begin your next design, consider exploring their broad portfolio of product lines and supplier partners on their website. For today's episode, Tim and I will take a look at our August 2026 issue, featuring our annual European Microwave Week show issue and a special focus on millimeter wave technology. This issue explores many of the technologies shaping the future of RF, microwave, and millimeter wave design. Highlights include Tim's EUMW 2026 preview, Radiating Change Microwaves for a Sustainable Tomorrow, along with this month's cover feature, The State of the Compound Semiconductor Industry in the UK. Co-authored with Rob Smith of CML Micro, Joe Gannicliffe of CSA Catapult, and Stuart Cornelius of Octech Semiconductor. As part of our EUMW coverage, Microwave Journal will also provide extensive content before, during, and after the event. Our EUMW 2026 microsite will serve as a central resource for conference news, exhibitor updates, product announcements, and reports from Microwave Journal editorial team throughout the show. Tim, your EUMW preview sets the stage for this year's conference, but this month's cover feature takes a deeper look at another important topic. You co-authored The State of the Compound Semiconductor Industry in the UK. What prompted this article, and what are some of the key insights readers can expect?
Well, thanks, Jen. Well, I looked back at the last European Microwave Week and when it was held in London. So as you know, I came to microwave with a background in compound semiconductors, working with gas and GaN mimic amplifiers and such. I thought it would make an interesting story to see how much the industry has changed in this last 4 years, and specifically within the UK. I was fortunate enough to have some good contacts in the UK to help me pull this together, and I learned a lot. I suspect a lot of our US readers will be surprised to hear about the leading edge technology being developed over there. I, for one, was surprised to learn that the very first radar systems were developed and deployed in the UK, and the first gas mimic is also credited as having been built there. Another thing that came out of my research showed that as the stability of international relationships has begun to wobble, the UK government has stepped in to own and manage and control its in-country compound semiconductor ecosystem. I hope our readers find this piece as interesting as I did researching it.
And in addition to our EUMW coverage, this issue includes several technical features exploring important trends across RF integration, semiconductor technology, and next-generation wireless systems. Two articles that caught our attention look at the future of RF integration and front-end architectures. The first, Toward a Monolithic Silicon RF Front-End Module Through 3D Sequential Integration, The Next Step in RF Integration, by Luca Lucci of CEA Leti, explores how advanced 3D integration approaches could enable new levels of RF system integration. The second, Beyond Static Coexistence, Architecting Non-Stationary RF-FE Systems for Multi-State Devices, by Skywark Solutions, examines how RF front-end architectures are evolving to address increasingly complex multi-state device requirements. Tim, can you give us an overview of these two articles and explain why these developments are important for the future of RF system design?
Sure, Jen, thanks. For those who aren't familiar with them, CEA Leti is a world-leading research institute in micro and nanotechnologies. They're based in Grenoble, France. Their article in this month's issue focuses on the future of RF integration. Their researchers describe the use of 3D sequential integration to develop a fully integrated RF front end. This implies a lot more than just integration in like a system in a package. It previews a platform that combines the best-in-class silicon RF technologies into a single monolithic chip. For example, they suggest using SiGe HBT for low noise and high power amplifiers. For the switches, they use silicon on insulator with trap-rich substrates. They still use standard CMOS circuitry for control and digital processing, and then a special trap-rich substrate to build the high-quality passive components. But rather than forcing all these different devices into a single planar process flow, the article proposes the use of 3D sequential integration stacks to vertically integrate these technologies, one on top of the other, on the same starting wafer. To be sure, there are a number of challenges to building such a multi-tiered solution, not the least of which is managing the thermal properties of the various levels. But I suppose if we ever hope to build drones the size of dragonflies or even mosquitoes, this is the direction RF integration is going to take us. Readers should check this article out. I think it's pretty interesting. The article from Skyworks, while also focusing on RF front ends, takes us in a much different direction. Here's the gist of it. Traditional front-end designs for cell phones had a somewhat static set of variables to work with, but the growing number of what the author refers to as multi-state wireless platforms now need to operate in a much more complex environment. Take, for example, the latest foldable phone model. The antenna and the rest of the RF front-end has to work whether the phone is open or closed. This article introduces the concept of dynamic isolation gap, which is defined as the state-dependent variation in antenna isolation that occurs when a device changes mechanical configuration. This paper examines how these mechanical changes degrade higher order modulation performance and other parameters, and then proposes a predictive coexistence framework in which device state awareness replaces fixed margins with adaptive, context-driven protection, offering a scalable path for RF front-end design as platform complexity grows.
Another highlight from this year's European Microwave Week is the EUMW Defense Forum, bringing together experts from industry, government, and academia to discuss RF and microwave technologies supporting defense and security applications. It's one of several new initiatives attendees can look forward to at this year's event. And whether you're attending EUMW in person or following along remotely, be sure to visit mwjournal.com/EUMW 2026 for the latest updates, including conference news, exhibitor highlights, product announcements, and daily reports from the Microwave Journal editorial team. We'll also be taking a closer look at our millimeter wave technology special focus in an upcoming episode, including the collection of articles available as a standalone PDF ebook. Tim, what did you see in the news this week?
Thanks, Jen. GlobalFoundries announced it has entered into a letter of intent with the U.S. Department of Commerce to accelerate research and development of next-generation silicon photonics, the optical technology that moves data at the speed of light and underpins the AI and high-performance computing data centers driving the global economy. Under this LOI, the department's CHIPS Research and Development Office is expected to award GlobalFoundries $300 million to advance next-generation optical materials, wafer technologies, and advanced packaging, reinforcing U.S. leadership in a technology that is considered essential to AI infrastructure. Silicon photonics enables ultra-high bandwidth, energy-efficient data movement by transmitting information with light rather than electrical signals, delivering greater performance, higher interconnect density, and lower power consumption as AI and data center workloads scale. GlobalFoundries' silicon photonics platform is enabling today's pluggable optical interconnects and is uniquely positioned to enable the industry's transition to near-packaged optics, NPO, or co-packaged optics, CPO. I've been reading more and more about the advances in optical networking and the intersection of this technology with the microwave world. This will be an area Microwave Journal will continue to monitor and report on. Cadence was also in the news this week with the announcement of the industry's first fully autonomous virtual agentic AI design engineer, extending their ChipStack AI super agent to level 5 autonomy. Built on Cadence's AI-driven EDA portfolio with NVIDIA Nemotron models, not SpongeBob's nematodes, but Nemotron models from NVIDIA, the new agentic capabilities enable customers to run dynamic simulations and automated workflows. At NVIDIA, thousands of engineers are using billions of compute hours per year to run millions of tests to verify their designs. Each engineer will use ChipStack agents to run hundreds of dynamic simulations with Cadence Xcelium logic simulation and Jasper formal verification, delivering over 40 times faster RTL validation cycles and reducing a typical 5-week verification loop to less than a day, dramatically accelerating the validation of complex semiconductor designs.
Last week, I had the opportunity to attend a recent CABI Lunch and Learn hosted by Remtech. It was a great chance to learn more about the company's advanced ceramic packaging technology, substrates, circuit boards, and assembly solutions that support the defense, aerospace, microelectronics, and broader electronics industries. Beyond the technology, it was impressive to see Remtech's impact on the local economy and its role in strengthening U.S. manufacturing. Thanks to CABI and the Remtech team for hosting such an informative event. And before we wrap up, Tim is just returning from Dallas, Texas, from the 2026 IEEE International Symposium on Electromagnetic Compatibility, Signal, and Power Integrity, also known as EMC-SIPI, which took place August 3rd through the 7th. Look for Tim's wrap-up article covering the latest developments in EMC, signal integrity, and power integrity, and bringing back insights and industry updates to share with Microwave Journal readers. Also coming up, we'll be hosting an online panel on August 26 focused on digital twins and AI. Experts from across the industry will explore how simulation, measurement data, and AI-driven analytics are changing the way RF and microwave systems are designed, tested, and optimized. It's a great opportunity to learn how these technologies are helping accelerate innovation in areas like aerospace, defense, and next-generation communications. And once again, we'd like to thank RFMW for supporting Frequency Matters. RFMW is a technical distributor of RF, microwave, and power management products. As you begin your next design, consider exploring their broad portfolio of product lines and supplier partners on their website. And please remember, if you are a member of the RF and microwave industry, a subscription to Microwave Journal is free. Visit mwjournal.com to learn more and sign up. That concludes this episode of Frequency Matters. Thank you for watching, and we'll see you next time.